Welcome to 2819. I'm Sandra Dimes.
And I'm Daniel Lamagir.
And today's topic is on design to the core. Let's show them the book.
Design to the core?
Yeah, I read
You mean
that
the
book.
latest book by Dr. Hugh Ross?
I sure do.
With this nice holographic,
I know.
shiny. One of the 10 correlations between people and humans. I mean, fish and humans, they like shiny things.
People and humans.
People and humans are the same thing.
I do like shiny things.
Yes.
I'm either a fish or a human. One of those.
One of those, or a mixture of both.
Mermy. All right.
In Everyday Apologetics, we'll hear from Hugh Ross and Fazale Rana on the fine-tuned hypernova rate.
And in Science Faith Connection, Jeff Zorink will talk with Ken Wolgemuth on geological evidence for design.
First up will be Culture Talk. Sandra will be interviewing Dr. Hugh Ross on the rare galaxy hypothesis, which he discusses in his new book, Design to the Core. So let's go ahead and check it out.
Now it's time for Culture Talk, where we talk about culturally relevant topics that you can use to start conversations about your faith. And I'm joined today with astrophysicist Hugh Ross. Thank you for joining us.
Oh, you're welcome.
We're going to be talking about your new book, Design to the Core. Super cool cover, nice and shiny.
Well, our editorial team designed that, so thank you for the editorial team.
You're welcome. So, I love this book. I not only love the cover, but the contents in it. You take readers on this journey through the cosmos, and you use a lot of big words. I think some people will be very surprised to know that things like large-scale cosmic structures and the Earth's crustal interior, that all of those point to fine-tuning, and to think that we can look through the cosmos and find something that points to a reason for us to be here, I think is pretty spectacular, and you've done such a good job in unpacking that in this book. Can you walk us through a couple of those features, specifically, and this is a big one, it's a head scratcher for me, I'm not even sure I'm going to say it right, Laniakea supercluster? It's a supercluster.
It's a supercluster.
And can you say it?
Yeah, supercluster.
No, not that one. Very funny.
Laniakea.
Laniakea?
Yeah,
so
that's a Hawaiian word.
Yeah, so that supercluster, how does that point to a designer?
Well, it's a new word. It didn't exist in the English language until they actually figured out what a supercluster is. It's a cluster of clusters of galaxies.
Okay.
And basically, they define it as a grouping of clusters and groups of galaxies that are gravitationally connected. So they're basically falling into a common center. Now, that's assuming you take out the expansion of the universe. What's unusual about our Laniakea supercluster, it's actually dispersing. But they define it by saying, okay, what are the velocities of galaxies if we take out the general expansion of the universe? But that's unique to our super galaxy cluster. The ones that we see elsewhere in the universe are gravitationally stable. In other words, they're very dense groupings of huge galaxy clusters. And when you look at them through the telescope, they look like basketball or football type structures. So you see all these galaxy clusters densely packed together. Dangerous place for advanced life, because you're going to have some really big supermassive black holes pouring out deadly radiation. The galaxies and stars are going to be way too close together. You're going to have gravitational disturbances throughout that system. What's unique to our super galaxy cluster, it doesn't look like a basketball or a football with dense clusters packed together. Rather, it looks more like a praying mantis insect. You ever looked at those spindly?
Yeah.
And so you see these small galaxy clusters. There's a couple of big ones in the Laniakea super galaxy cluster, the Virgo cluster, for example. But most of them are small galaxy groups strung along these long filaments. And that's a unique feature. And like our local group of galaxies is at the nexus of 3 subfilaments. And so we see these galaxies and galaxy clusters and galaxy groups strung on along these very long lines. But that means that you can have a grouping of galaxies with a galaxy inside of it where it's not going to be gravitationally disturbed, where it's not going to be exposed to deadly radiation from these really big supermassive black holes. and yet it's going to have enough tiny dwarf galaxies in its vicinity that the galaxy in which you have advanced life can consume these tiny dwarf galaxies, because that's critical to sustain the spiral structure of the galaxy. You need a stable, symmetrical spiral structure for advanced light to be possible. And Sandra, there's tens of thousands of these super galaxy clusters in the universe, but ours is the only one that has the features that would permit the existence of advanced life.
Yeah.
All the others we look at are radically different from our super galaxy cluster.
I love that. I love that you're explaining, kind of as we're going through this journey through the cosmos, we're seeing all of these other galaxies and superclusters and clusters that are showing, nope, we can't have life here, but here we can. And so that's helping, I hope the lay reader to understand that when you start to look at far out into the cosmos, you can see all of these places that are beautiful, but we can't have advanced life there.
That's another part of it. There's beauty everywhere you look. And so, why is it so beautiful? It's like it shows the personality of the Creator. And He put within us human beings a capacity to appreciate beauty. And the heavens really do declare the glory of God, not just the stars in our Milky Way galaxy, but the galaxies beyond, the galaxy clusters beyond, the super galaxy clusters, the cosmic web. And the book really starts with the universe as a whole, because there's over 50 books in my office written by mainly unbelievers who talk about this amazing design of the universe, but they're looking at the universe as a whole, which allows them to keep the Creator at an arm's length. What I do in this book is say, let's start there, but then let's move gradually, step by step, towards planet Earth. And you see that the level of fine-tuned design gets greater and greater and greater, and it's at all cosmic size scales, not just one or two.
Yeah, well, you start large, at the large scale cosmic structures, then you go all the way down. And I love this idea of zooming in. So you zoom in now to Earth's interior. So we've traveled light years to now get to Earth's interior. And what is so fine-tuned about our planet's interior?
Well, the sun's interior is fine-tuned, the moon's interior is fine-tuned, the Earth's interior is fine-tuned. The Earth is where we see the most spectacular interior designs. The fact that it has a solid iron core, a liquid iron core beyond that, a couple of mantle layers beyond that in the crust. And I think what you're referring to is the incredible design of what's called the asthenosphere.
Oh, I was totally referring to that.
Oh, yeah. It's a very thin layer between the outer crust of the Earth and the outermost part of the mantle of the Earth. But this is where you have what's called the deep water cycle operating, the deep carbon dioxide cycle operating, the deep water, deep oxygen, and how all of these cycles have to be fine-tuned at different rates throughout the history of the Earth. And it takes this incredible relationship between the solid core, the inner core, the inner mantle, the outer mantle, the asthenosphere, and the crust of the Earth to ensure that we're getting these cycles operating at highly fine-tuned levels throughout Earth's history. And if that weren't the case, we wouldn't be having this conversation. We wouldn't even exist.
It reminds me of something that one of our friends, a science teacher, Mark Ritter, used to say to his students, that, you adjust anything one way or another, and what happens? The students say, we all die. And I thought it was funny, but it's such an interesting thing to learn that it is so finely tuned that we tweak things a little bit and advanced life can't exist.
What this book talks about, there's over 2,000 things where you run into that.
Wow.
Fine-tune them ever so slightly, we all die.
Right.
But what I really love is it's all fine-tuned, not just so that we can exist, but so that billions of us on one planet can be redeemed from our sin and evil. That's where you see the most astounding fine-tuning. Well,
there is a lot in this book, and I am excited for our readers to finally get their hands on it, because it's available now broadly, pretty much wherever people can buy books. So I'm very excited. Thank you so much for just coming in and talking about your book. If you want to get this book, Designed to the Core, go to support.reasons.org.
But we live on a planet that seems to have the just right abundance of molybdenum in its crust. And so we have very few incidences of molybdenum poisoning and very few incidences where people don't have, the vast majority of the population has precisely the amount of molybdenum that they need in their bodies. So just an argument for design.
Yeah, it's fascinating. Well, and then to even extend it, the argument, and I've heard you make this point before, it's not just simply that, that we have the enrichment of elements in the Earth's crust that make life possible, but it's also, it makes advanced civilization possible. So it seems to me like with molybdenum, you could actually make both types of fine-tuning arguments, not only for life, but for
the industrial applications are important. We wouldn't have the advanced civilization we have if we didn't have the amount of molybdenum. So the fact that we live on a molybdenum-rich planet really helps explain our high technology civilization.
I've not done any of this work, but as I'm here listening to you talking, it seems to me that this is an opportunity to develop kind of a prediction, a scientific prediction that we could test. And it would be interesting to, I don't know much about molybdenum and its role in biochemical systems, but it'd be interesting to find out what is special about that metal when it's incorporated into enzymes as a cofactor that makes it so useful. And I would predict that you're going to find that molybdenum has these just right properties that you can't replace, that there's not alternatives to the molybdenum enzymes. And so that
you're exactly right. It's the only element in the periodic table that binds with oxygen in such a way as to form a particular geometric pattern that allows certain proteins to function. So if people go in the Wikipedia article on molybdenum, they'll actually see this incredibly complex three-dimensional structure that's crucial for these cofactor enzymes.
Yeah. So, I mean, that would extend the argument, right? That where you would say that not only is, so in other words, it's not simply that, life is adapting to what's available, right? And creating molybdenum enzymes because that molybdenum is available, but rather if molybdenum wasn't available, there's a certain range of biochemical functionality that wouldn't exist that makes life possible. So,
you'd be missing certain proteins, and without those proteins, no life is possible anytime, anywhere in the universe. You got to have molybdenum.
Well, and it may seem like a subtle point, but I think it's really important because you hear skeptics oftentimes say, well, it's just like the water that finds itself in a puddle saying, isn't it amazing how ideally shaped the puddle is, for me, right? And so the idea here, to take that objection and then talk about it in terms of, evolutionary theory, you would say, well, life again is just evolving based on what's available in the environment. But I think really what is behind the anthropic principle is the fact that we live in a universe where concave surfaces are even possible. Right. That if things were even slightly different, we'd be in a universe where only flat surfaces or convex surfaces are possible, not concave surfaces. And I think that's really, the point here, right, is that it's a necessary component for life and life simply wouldn't be possible without it.
Yeah, and that's true of virtually every element in the periodic table. I mean, the reason I made the table in Improbable Planet is like when you look at the periodic table, virtually every element there is anomalous with respect to the Earth. The Earth is either super abundant in the element or super underabundant. And that underabundance or overabundance is exactly what life needs. And so we're not going to, that's one argument why we shouldn't expect life to be on all the planets in the universe, is that those planets aren't going to have the right abundance ratios of the periodic table elements.
Hello, Jeff Zwerink. Welcome back to Science Faith Connection, the segment of our show where we explore important scientific ideas and see how they relate to the truth of Christianity. I'm excited to have Dr. Ken Wolgemuth back on the show, and we're going to look at how the earth is designed to support life. Ken, good to have you here today.
It's good to be back again after so long.
So I know Dr. Ross has come out recently with a book, Designed to the Core, that talks about just the design across the universe, how it goes from the supercluster to the local cluster to our galaxy planetary system. And I know you've done a lot of work looking at geology and how the earth works. So where do you see, or how do you see that fine tuning or design playing out when we're looking at the earth itself?
First step is that the solar dust or the nebular dust that made up the earth as part of our solar system had particularly just the right amount of radioactive atoms, particularly uranium, thorium, and potassium-40, that gave the opportunity and caused the earth to have just the right amount of those radioactive atoms to generate the heat in the earth that was necessary. So that's the starting point.
So normally you think of radioactive stuff as being detrimental to life. Kind of just map out a little bit more detail. Why is having radioactive material important for what's going on in the center of the earth, where the radiation doesn't affect life per se?
The point is that as the earth correlated, the gravitational heating of the rock and the material did not get it hot enough. And so those radioactive atoms that were mixed in with the stardust were just in the right proportions that it has caused the interior of the earth to have a molten core. And so that's where the really significant piece comes in. The radioactivity here in this case is the issue of heating the center of the earth, the core, to high enough temperatures to be a liquid.
So this is kind of like where we put radioactive thermal generators out on rockets as a way to heat things up. Effectively, these radioactive elements are heating up the interior of the core, or the interior of the earth, so that it does what that makes Earth habitable.
Well, the final result with that molten with a molten core, because of those radioactive atoms, that has caused the Earth to have a very major magnetic field of a magneto for most of its history, for a lot of its history. But during the time window of that history, as cooling did gradually occur, the very inner part of the core ended up becoming a solid because of the slight cooling and the just super high pressures. So now the core of the Earth is a mixture of a solid internal core surrounded by a liquid core that then transitions into the mantle at a boundary between the outer core and the mantle.
So, okay, so we've got the structure of the Earth. You've got rigid tectonic plates on the surface. You've got a boundary between that and the mantle. The mantle goes down to this liquid core that has a solid inner core. Why is that important for the magnetic field here on the Earth?
As the Earth heated up and the inner core, as the core became liquid, the heavier elements that have the capacity to form a magnetic field, that is primarily iron and nickel, are those that can cause a magneto to occur, did in fact do so about 3.5 to 4 billion years ago. And so we have had a long-term magnetic field throughout the life of the Earth. Then as the cooling began to take place over a number of billions of years, about 1 billion years ago, or maybe 600 million years ago, that solid inner core formed, and between the interaction between the solid inner core and the convection currents in the outer core trigger what has turned out to be a very stable, long-term, basically magnetic field. And the significance is the magnetic field surrounds the Earth, and it is what protects life from solar radiation and from the cosmic radiation that is completely deadly to any life on the surface of the Earth.
Well, that's something where you're touching on my research. Did research in gamma rays, cosmic ray physics, and it is just startling to me when I recognize that if you were to take a plate or a detector, a square meter in size, put it up on top of the atmosphere, you're going to get 1,000 high energy cosmic rays hitting that plate. So there's an enormous amount of radiation that the magnetic field diverts away from the surface of the Earth, a lot of it up to the poles, and that's very critical for Earth, or just eliminates a lot of that radiation. Especially, I find that interesting that you said that right around 600 million years ago, because that's when large-bodied organisms started arriving on Earth. I presume that's not a coincidence in your assessment.
It certainly isn't. And in fact, the fine-tuning of the nature of the concentration of the Earth to have that iron and nickel in the middle core has about 5 different parameters. They're have to be at a very tight, limited value for the whole piece to fit together, so that we have that long-term stable magnetic field that protects us. And there are about 8 different parameters that I'll mention that are in Hugh's book. Number 1 is the Earth's mass needs to be very tightly constrained. The mass that's in the core of the Earth itself, that is that liquid core. The viscosity of the mantle is at a very narrow range in terms of its transmission of heat up toward the surface. The thermal conductivity of the core itself, that is the rate at which the heat dissipates out. The initial temperature of the core when it was first formed 4.5 billion years ago. And then the composition of the inner core and the outer core with that very high, almost 95% iron nickel core, which gives us the magnetic field that is long, stable, and protects all life.
No, I don't think anyone disputes the importance of the magnetic field, Earth's magnetic field, protecting life. But I do know when you look through our solar system, there are lots of bodies that have magnetic fields. I mean, Jupiter and Saturn have pretty strong ones. And so what is it about, how is it that you're claiming that if other bodies in our solar system have these strong magnetic fields, what makes Earth so unique or fine-tuned in your assessment?
It turns out of the, what are called the rocky planets, that is from Mercury, Venus, Earth, and Mars. Earth is the only one that has a strong magnetic field that is stable and lasting. Mercury has a slight magnetic field, but it is far less, has a far less strength than the Earth has. The large planets have magnetic fields, but they are out beyond the range of where life could exist anyway, because there's no liquid water that is necessary for life. So the Earth is significantly in what is referred to, if you will, as a Goldilocks zone, right here in the right distance, exactly the right distance from the sun, and to have this magnetic field that is strong enough to deflect all the massive amount of solar radiation and cosmic radiation that's ready to just kill all life on the surface if the magnetic field were not here.
Well, thanks, Ken. I really appreciate your comments. When we look at the Bible, we see that, as Isaiah said, that God did not form Earth as a waste place, but formed it to be inhabited, that we would expect to find evidence that God has worked to design the universe and the Earth so that it can be habited. And we find abundant evidence of that. I'd encourage you to go to reasons.org. Check out Ken Wolgemuth's page. Search for Wolgemuth. You'll get access to a lot of his resources that he's produced that point to that fine-tuning and design. And also go check out Hugh Ross's latest book, Designed to the Core, for a great wealth of information of how God has fabricated this universe so that we can be here, and how we can use that evidence to go tell others about God.
We hope this episode has helped equip you to share your faith with compassion and confidence.
I really enjoyed learning more, even though I read this book like 3 times. I loved hearing from Hugh and talking about just this journey from the big to small, going from far, far reaches of the universe down to the Earth's core. My goodness, the fine tuning is just amazing.
Right, and I love how he says so many things point to the reality of a creator.
Right.
And I love how he talks about how, and he created it all like for us to be able to exist, like these very precise exact measurements. So it's a great read.
And don't forget, subscribe to the show and search for us on Facebook, Twitter, and Instagram. We are at 2819 Show. We'd love to hear your thoughts.
And if you want the audio version of the show, you can find us on most major podcast services. Just search Reasons to Believe Podcast.
See you next week.
See ya.